So in the last lecture, we discussed about the last lecture we discussed about stress. So now we will come to the next important parameter, strain. So strain basically is the elongation upon the original length, the change in length upon original length. This is how we define strain. Suppose this is a rod or prismatic bar. Force P is applied. So due to this force, there will be certain change in length. Here in this bar, if we consider an imaginary cut section, so as discussed earlier, because of this because of this force P, some internal forces sigma, which are the stresses, will be developed inside this bar. Because of this stresses, there is going to be certain amount of deformation. So this deformation divided by the original length of the bar is known as strain. So here in this case, we have defined normal strain is normal stresses upon original length. It will be known as normal strain. Here, as we can see, this prismatic bar is the change in length here has been denoted by delta. So this delta upon the original length is known as strain. So if this prismatic bar, is in tension, so the strain, that is the deformation upon original length, this strain will be known as tensile strain. Similarly, if this bar is in compression, we are trying to compress the bar, then the resulting strain will be known as compressive strain. So in general, the strains associated with normal stresses are known as normal strains. So similarly, if the stresses are associated with shear stresses will be known as shear strain. So as we know that the strain is change in length upon original length. So it is a dimensionless quantity. It has got no dimension. Now we'll just take up this small problem. Suppose there is a prismatic bar of cross section 25 by 50 and length of this bar is 2 meters. It is subjected to an axial tensile force of 90 kilonewton. So the measured elongation of the bar is 1.5 Compute the tensile stress and strain in the bar. So the dimensions of the bar are given, and it is subjected to a load of 90 kilonewton. So the elongation has been measured as 1.5 We have to compute the stresses and strain in this bar. So let us first see what are. We know that the load is P, 90 kilonewton, length is 2 meters. Area can be computed from the dimensions given, 25 into 50 So the change in length here has been denoted by delta, that is 1.5 So the stress will be P upon A, the force upon area. So the force is 90 kilonewton. So 90 into 1000 upon 25 into 50. This is P upon A, force upon area. So the stress has been computed as 72 Newton per square. The SI unit of strain SI unit of stress is Newton per square or MPa, megapascals. 1 Newton per square is equals to 1 MPa. So now similarly we'll compute strain. Strain is the change in length upon original length. The change in length is 1.5 meters, 1.5 mm. original length was 2 meters, so it is 2000 mm. So if we come from here, we'll calculate. We have calculated the strain is 7.5 into 10 to the power of, it will be minus 4, 0.00075. So we know that the strain has got no units. So this is how we can compute the stresses and strain. If we note the change in length of like elongation of an object. So similarly, if this would have been compressive force, axial compressive force. So in that case, these values would be same. Only this stress would have been compressive stress, and this change in length would obviously would have been negative. Negative means the length would have decreased. Otherwise, the values of stress and strain would have remained same.